Hi guys, welcome back to part 2 of sequences. In this video we're going to be concentrating on how to find nth term of quadratic sequences. Part 1 was focusing on how to find linear sequences. The main difference between linear and quadratic is the fact that linear always has only n's and a constant, whereas quadratic will have n squareds and n's and constants. So if you're not really sure how to do linear sequences, I will highly recommend that you guys watch part 1 of the sequences so you can get the linear sequences sorted and then move on to the quadratic, because quadratic are obviously harder and they're higher level. So if you're not sure how to do linear, you're not going to be able to do quadratic. So it's really important that you watch linear sequences and then move on to quadratic. I'll still do a small recap on linear sequences. So anything that's in the form of a/n plus b is linear. Now what it actually means is, so if you have a sequence 2, 4, 6, 8, 10 and so on, obviously will carry on forever and ever. But in linear, you can see the difference every single time is +2. The difference is constant in linear sequences. So every single time you're adding 2. To get from 2 to 4, you're adding 2. To get from 4 to 6, you're adding 2. And you're doing that every single time. So if you want to find the next term after 10, all you have to do is add 2. So 10 plus 2 will give you 12, and then you found your next term of the sequence. That's very simple. However, with quadratic it's not quite the same. The difference is not going to be constant every single time, which is why it's harder. So I will say that again, if you're not quite sure how to find the nth term of linear sequences, please go back to part 1 of sequences, get those sorted, and only then move on to your quadratic ones. So let's take a look at an example here. We've got 10, 14, 20, 28, and it will obviously go on forever. But we're just going to concentrate on these 4 for now. Step number 1 is always going to be the same as linear sequences. So always write down the term number on top of the term of the sequence. So number 1 above the first term, 2 above the second term, 3 above the third term, 4 above the fourth term. If there was a fifth term, then just write 5 above the fifth term. The second step is to find the difference between each term. Well, to go from 10 to 14, you have to add 4. But to go from 14 to 20, you can see you can't just add 4 and get to 20. You have to add 6. And you can already see that it's not going to be as easy to find the expression to find the nth term, because the difference is not constant. Here you're adding 4, then you're adding 6, and then you have to add 8, okay? But however, you can see that difference each time is increasing by 2. So 4 add 2 gives you 6, 6 add 2 gives you 8, okay? So what you actually have to do is find the difference between the differences, and it's +2. And now you can see, oh, there's a number that's actually constant, okay? So if you've had to find the difference of the differences to get a constant difference twice, if you had to find it twice, then you're gonna get an n squared term, okay? The coefficient here depends on what the difference is. In this case, the difference is 2, but you're not going to put 2 here. It's always going to be the half of the difference. So 2, half of 2 is 1. So the coefficient here is going to be 1. The next step is to write down the term again. So let's write down 10, 14, 20 and 28 again. Then write down the value of the n squared. Now it's n squared because 1n squared is same as just n squared. So write down the value for n squared. So when n equals 1, 1 squared we get 1. When n equals 2, we get 2 squared, which is 4. When n equals 3, we get 3 squared, which is 9. When n equals 4, 4 squared is 16, okay? The third part of this step is to do term minus n squared, okay? So whatever you found out from this step, you take away from the term. So 10 take away 1 is 9, 14 take away 4 is 10, 20 take 9 is 11, and 28 take 16 is 12. The reason that we're doing this step is to find out the rest of the expression. This is the whole expression that we need to find out for quadratic sequences. We found out the n squared through this step, and we need to find out the rest. So we need to find out what the bn plus c is. And the only way that we can find out this bit of the expression is by this method here. So write down the terms again, and underneath it write down what the n squared values are, and then just take the n squared away from the term. So in this case we get 9, 10, 11, and 12, and it's this that will help you find out your bn plus c. So this becomes your sort of new sequence to find out bn plus c. So treat this like one of the linear sequences and find the formula for this. So to go from 9 to 10, you add 1. To go from 10 to 11, you add 1. And to go from 11 to 12, you add 1 again. You can see the difference this time is constant. It's plus 1, plus 1, plus 1. And how we discussed that for linear sequences, the difference every single time will be same, unlike here where it was plus 4, plus 6, and plus 8, okay? So this is linear because you're adding 1 every single time, and you write down n, and whatever the difference is goes next to the n, and in this case it's 1, but writing 1n is same as just a single n, okay? Then next step is to write down value of whatever this would be when you put n equals 1 or n equals 2, n equals 3, and so on. So when n equals 1, we just get 1. When n equals 2, we just get 2. When n equals 3, we just get 3. And when n equals 4, we just get 4. So then we've got this sequence, and then we've got the actual sequence. So we say, how do we get from this sequence to this? So how do you get from 1 to 9? Well, you add 8. So all you have to do is put plus 8 at the end. You can double check by saying, okay, how do you go from 2 to 10? Well, you add 8. How do you go from 3 to 11? You add 8. How do you go from 4 to 12? You add 8. So this is where the plus 8 comes from. The final answer is pretty simple. All you need to do is put this and put this together. So your final answer is just n squared plus n plus 8. So this is the expression to find the terms of this sequence. So let's take a look at another sequence here. Step number 1 is always to write down the term number above the term of the sequence. So 1 above the first term, 2 above the second, 3 above the third term, and 4 above the fourth term. So let's see the difference between each term now. So the difference between 6 and 10 is plus 4. Difference between 10 and 18 is 8, and the difference between 18 and 30 is 12. Well, we can clearly see that the difference is not constant. So let's find the difference again. So let's find the difference of the differences, and we can clearly see that every single time we add 4. Okay, so we know that our formula is gonna have an n squared because we found the difference twice to get to a constant difference, so n squared. Now we need to find the coefficient of n squared. Well, the difference is 4, but we said whatever goes next to n squared needs to be halved. So 4 divided by 2 gives you 2, so the difference is 4. However, the difference divided by 2 gives you 2, so the coefficient of n squared will be 2. Now you need to write down term 2n squared and term take away the 2n squared. There's 2n squared because that's what we found out from the step earlier. So write down the term again. So 6, 10, 18, and 30, and 2n squared. So when we put 1, n equals 1, we get 2. When n equals 2, we get 2 squared, which gives you 4. 4 times 2 gives you 8. When we have n equals 3, 3 squared is 9, and 9 times 2 is 18. And when we have 4, 4 squared is 16, and 16 times 2 is 32. Okay? Now what we need to do is term minus the 2n squared. So 6 take away 2 gives you 4. 10 take away 8 gives you 2. 18 take away 18 gives you 0. And 30 minus 32 gives you minus 2. Now what we need to do is make this our next focus. So we need to find the difference between them, okay? Now, we know the difference is 2, however, it's not just plus 2 because you're not adding 2, you're taking 2 every single time, so it's minus 2 every single time, okay? So this is to find out the linear part of the formula. So minus 2, and you can see that the difference is constant every single time. So write down your n, and whatever the difference is goes next to the n minus 2. Be careful, when you're doing the n squared, you always half the difference, whereas when you're solving the linear part of it, you always write down the difference as it is next to the n. The next part is to plug in values of n equals 1, n equals 2, and so on, and write them underneath the correct term, okay? So when n equals 1, this will equal minus 2. When n equals 2, this will equal minus 4. When n equals 3, this will equal minus 6, and this one will equal minus 8, because this is the fourth term, and we put 4 in, we get minus 2 times 4, which gives us minus 8, okay? We're almost there now. So we look at this sequence here and we say, how do we get from this back to the linear sequence? So how do you get from a minus 2 to a 4? How do you get from a minus 4 to a 2? How do you get from a minus 6 to a 0? How do you get from minus 8 to a minus 2? Well, it's quite obvious that every single time you add 6 to get back to the original sequence, the original linear sequence. So all you need to do is put plus 6 at the end, because every single time you need to add 6 to get back to the linear sequence. Last but not the least, the step is put these two together. So 2n squared and this, and you get 2n squared minus 2n plus 6, and this is the main expression. After you found out your expression, you can obviously use this to check if what you've actually done is correct. So if you put the value of n equaling 1, you should get 6. If you put n equals 2, you should get 10. If you put n equals 3, you should get 18, and so on.